Right. Good evening, everyone. I hope you can hear me, and then thank you very much for joining. Right, with all the hustle and the bustle in the country, Neil. Right. I'm sure you are eagerly waiting. But then, right, even after today, life goes on. Right. So we need to face that. Right. Okay. I hope you can hear me. Can you hear me? So, right. Excellent. Yes. So, this is today is the paper number 13. Let's start, right? Let's begin with this journey. See whether we can come up with some good answers. Question number 1 here. I hope you can see it. Question number 1. The cathode ray experiment show the presence of, what is that? What is your answer? Electrons in an atom. Electrons in an atom, not neutrons, not protons, nothing else, nucleus, nothing else. First answer is the answer. Answer number 1, right? I don't think you need any explanation on that. Electrons are the ones that appear as cathode rays, right? So they are kind of simple ones, right? Question number 2. Purple light has a wavelength of 10 to the power minus 7, 4 10 to the power minus 11. How much of energy does a photon have? E is equal H C divided by lambda. Is it clear? Hc divided by lambda. H is equal to, what is that value? Right. Let me just get it a little thicker. H is 20 divided by 3. 10, that is too much. Right. 10 to the power minus 34 joules seconds. Velocity of light, 310 to the power 8 meters per second. So what is our lambda here? What's the lambda? Lambda is 410 to the power minus 7. 410 to the power minus 7 meters. Let us simplify some of these things. Meters and meters cancels out. Seconds and per seconds cancels out. 3 and 3 cancels out. 4 times 5, isn't it? So 10 to the power minus 7, 10 to the power 8 is 15. 15, 34, what is that? 19. Is that the answer? 10 to the power 19. So roughly 5, 10 to the power minus 19 joules. So what is the best answer? What is the best answer? Well, yes, third answer is the right answer. Third answer, right? Third answer is the right answer. There. Is it clear? Did you understand that? Fully? Fully, huh? Right, okay. So we have done enough of those questions, right? Okay. Right, next one. Which of the following has the incorrect electronic configurations? Phosphorus. Okay. So to do that, let us get a periodic table. Let's see whether I have a periodic table. Yeah, there you have a periodic table here. So let's take that periodic table and try to kind of work it out from there. Phosphorus. What is phosphorus? Phosphorus, if I mark that, okay, right? Okay, just a minute. Right, phosphorus. If I mark the phosphorus here, where is phosphorus? Phosphorus is here. So this is after neon. So it is phosphorus is neon. Neon configuration. What else? After that, phosphorus neon 3s2 3p3. That is okay. The second answer is that is correct, right? Then you say calcium. Calcium, where do you have calcium? Calcium is here. This is our calcium. I don't know whether you can see it. Calcium is that. Let me get the laser point. I sometimes forget about that. So this is calcium. This is where the calcium is. Calcium is after argon. So we can write it as argon. Right? Argon configuration. And then what is that? 4s2 is the configuration. That is wrong, isn't it? It says neon 4s2. So second answer is the wrong answer there. So I will mark that as the second answer here. Second answer is the wrong answer. But look at the other ones. Copper. Copper is here. Here. Copper is here. So it is 3D. So that means argon, 3D 4s2 and 3D 4s1 and 3d10, because there's a electronic change. Zinc. Zinc is here. Zinc is here means closest electronic configuration is argon. Then you have 3d10 out of that, and 4s2 is configuration. Vanadium is 3d3 and 4s2. I think that is correct. The wrong answer is the second answer. Would you agree with that? Do you agree with that, children? Children, wake up to that, right? Everybody? Okay? Yes. Right. Okay. Now, question number 4. Let us see whether we can work out that answer as well. Question number 4. A, B, C, D are 4 consecutive elements in the P block. Actually, in the paper, it is given as file P. Something has gone wrong there. But I gave the correction in the group today morning. Like, since some of you asked this, what is file P? And when I start reading it, I realized that it is wrong. So I immediately send you the corrected version. So it should be, if you haven't accessed the group, consecutive elements of the P block, right? Its first ionization energy variation is in the order of A, C, B, D. So these are all P block elements. That means group 13 to group 18, right? Group 13 to group 18. These are the elements that are there. So what I do is, I told you, usually what we do is we draw the ionization energy variation. That's the best thing to do, right? Ionization energy variation. Let us draw that, right? So this is called the ionization energy variation, I1E, right? This is how the variation takes place. This is the first one, this is the second, then the third, then fourth, fifth, and then comes sixth, then seventh, then eighth, right? So if it is P block, we don't consider this one. So this one we are not going to consider because this is S, this is also S. P block starts from the remaining ones. So A, C, B, D. A is smaller, C is little greater, and then B is even greater and D is even greater. Can you see the variation? You have A here, you have B here, C here, and D here. So compared to this, A is the first one, then comes C, then comes B, then comes D. So 1, this is the second one, this is the third one, this is the fourth one. So that is the variation that you can see. That is the only place where you can see this kind of a variation. Did you understand that? So what is this? These groups? Can you tell me what are these groups? 1, 2, 3, 4. This is group 14. So dark red in color. This is group 15. This is group 16. This is group 18. Did you understand that, children? Is it clear? Right? 16, 8, 17. Yes. 17. Yes. Did you understand that? Right. Let me erase that and mark that. It is 17. Right? Everybody understood? So the hydride, so that means C means group 16. What are the elements in group 16? Can you tell me? What are the elements in the group 16? Look at the periodic table. This is group 16. Yeah. This is group 16. This one. These are the elements in group 16. Oxygen, sulfur, selenium, tellurium, polonium. Right? Yes. So you have oxygen, you have sulfur, you have selenium, you have tellurium and polonium. And it says hydride. What is hydride? What is hydride? Hydride means what? The compound that you get combining with hydrogen. Hydride is a compound that you get combining with hydrogen. So what is the hydride of oxygen? Your very famous molecule, right? Yeah, it's H2O. Hydride of sulfur, what is that? Hydrogen sulfide, H2S. Hydride of selenium, what is that? H2 hydride of selenium. What is that? H2SC. Yes, exactly. Hydride of tellurium is H2Te. Right? Now, polonium is a radioactive element. We don't consider that. So, which one is the liquid here? Something that you already know. Something is a liquid here. You know, this is the one that is in a liquid form. So, you're talking about oxygen. Hydride of C in the liquid form. That means C is oxygen. This is oxygen. Neither. Is it clear? That is oxygen. And what do they ask? Here A can be. What is A? So A means it belongs to group 14. What is the element that belongs to group 14? That is oxygen is here. This one should be carbon is the answer. Did you understand that? So this should be carbon is the answer. Carbon is the answer. This is second answer. Now I saw one of your friends ask me this question. Kovalan, there was a question now. Somebody, did you delete it? You have deleted it. Okay, right. So it's gone now. Somebody asked this question and then maybe you found the answer. Right. Okay. That's good. That's good. Finding your answer on your own is a really good thing. Right. That's a very good thing. Right. That's what we are trying to go aim at. Right. Okay, Buddha, everything is okay. Everything, I hope you're all right, crystal clear up to now. Yeah, right. Let us look at the next one. Which of the following sets of elements is written in the order of the increasing metallic character? Right. Okay, so in order to get that metallic character, I'm going to again look at, yeah, just a minute. There was this periodic table. Where is the periodic table? There you have. So let us look at the periodic table because these are all periodic variations. Right. Okay. So it says, now what happened to the metallic character? Now tell me what happens to the metallic character. When you go from this side to this side, what happened to the metallic character? Metallic character, what would happen? Metallic character decreases. Metallic character, metallic property decreases. When you go from this side, what would happen? This side to this side, what happened to the metallic character? What happened to the metallic character? Here. Metallic character increases. Did you understand that? When you go down the group, what happened to the metallic character? Metallic character increases. In that direction, what happens? Metallic character decreases. Right. Okay. So if you understand that those properties in it, now you can say sodium, lithium, potassium. Sodium is here. Let me, rather than drawing it, I will draw this one, right? Sodium is here, then comes lithium, then comes potassium, right? Lithium, sodium, potassium. I think that doesn't have like it decreases and then increases. That is wrong. Second one, carbon, nitrogen, oxygen. Carbon, nitrogen, and oxygen. These ones. So we are going in that direction. You can see metallic character decreases. Magnesium, aluminium, and silicon. Where is that? Magnesium is here. Aluminium and silicon. Again, the metallic character decreases. Beryllium, magnesium, calcium. Beryllium, magnesium, and calcium. What do you think? What do you think? Beryllium, magnesium, calcium, I think that increases, isn't it? So therefore, that is the right answer. Beryllium, magnesium, and calcium. So metallic character increases. Increases is the fourth answer. Is it clear? When the metallic character decreases, electropositivity also decreases. Yes, yes, that is true. Fourth answer is the right answer. Is it clear? Everyone? Right. Oh, very good, very good. Right. Let us go to the next question. Next question is question number 6. See whether we can work it out. Which of the following is an isoelectronic series? What do you mean by isoelectronic series? What do you understand by the term isoelectronic species or isoelectronic series? Yeah. Answers done. Nikan indeba, saddara tu indeba. Right? Otherwise, you will fall sleepy, you come upset, right? So you don't want that to happen, right? Having the same number of electrons, yes, answers the answer. Having the same number of electrons. So same number of electrons. Same number of electrons. Hurry. Let us look at this one. Sulfur. Sulfur contains how many electrons? Now, first answer. Sulfur contains 6 electrons. Chlorine contains 7 electrons. Sulfur contains 16 electrons, 17 electrons. Yeah. So that is out. So that is not the answer. What about second one? So this is not the answer. Right? That is wrong. Huh? Second answer, let us look at that second answer. What do you think? Fluoride, chloride. Fluoride contains 10 electrons. Chloride contains 18 electrons. So definitely it is not the answer. No? So that is also wrong, right? Let us think about the third answer there. Third answer, Si2 minus, silicon contains 14. 2 electrons you gain, 16. Phosphorus contain 15. 2 electrons you gain. What is the answer? 17. So that is also wrong. Now you can see. Now fourth answer, let us look at this one. Oxide. 8 plus 2, 10. Fluoride. How many? 10. Neon. 10 electrons. Na plus, sodium plus, 11, 1 electron, 10. So I think that is a right answer. So fifth one, that is wrong. So fourth answer is the right answer. Would you agree with that? Haridhar? Yeah, that's the answer. Fourth answer. Very good. Fourth answer. Very good. Yeah, there was a question earlier. When number of electrons in the elements are equal, they are called yes, they are called isoelectrons, right? I think that is okay. But question number 7, right? Let's go to question number 7 and see whether you can we can answer that well, right? So you can see that you have improved, right? Right. So from the next chemi, can you please add questions related? You need to hurry. We will do it. Hurry. Let me do the teaching. Please try to learn. Hurry. Mama karandang hurry. So because there are certain things. So with tutorials you are working on that, and you can keep on revising it. There's a kind of a way that I do it. Right. So we'll work it out. I really admire your suggestion. I will do it, right? We will do it, okay? Right. So I have actually made these next 3 or 4 papers. I have made, it passe tika thing, right? Wait, there's a kind of way of doing this revision. It is not a revision, that is why. Question number 7, as the wavelength of a radiation increases, right? Wavelength of radiation increases. What happens there? What happened there? Radiation increases. What happens? C is equal to lambda mu. C, first one, C is equal to lambda mu, right? Right. If the frequency, what happens? Frequency increases, wavelength increases, frequency also increases. Frequency, lambda, frequency is equal to C divided by lambda. So when the wavelength increases, what happened to frequency? Frequency decreases. So therefore, A is wrong. Right? A is wrong. B, the speed of the light increases. Frequency goes up and the light speed of the light also goes up. That's right, no? Frequency increases. The speed of the light also increases. What is wrong with it? Speed of the light is a constant. It will never increase. It's a constant. So therefore, that is also wrong. Right. Good. C, the energy decreases. What can you say? C, if you look at it, E is equal to Hc divided by lambda. So whenever the lambda increases, to energy decreases, right? So I think that is right. C is correct. Right? D, intensity decreases. Nothing happened to the intensity. Intensity means how strong the it's called intensity. Intensity is a kind of primary unit. You see in your main units, like what do you call that? I can't remember now. Like, the length is meters. Likewise, the basic dimensions, basic fundamental dimensions that you think about. You have the length, amount of substance is moles, time is measured in seconds. Likewise, the light intensity is measured in candela, right? Intensity is that intensity of the light. So how strong the light is. In the daytime, the intensity of the sun is much higher. In the morning time, intensity is lower. How strong it's called intensity, right? So that doesn't change actually. Nothing happens to that. It depends on the number of photons, not the wavelength. So that is wrong. Only C is the right answer. What is the answer? What is the answer? Answer is the fifth answer. Agree with that? Again, is it clear? Intensity means the luminous index. I don't know whether it is luminous index. I have never heard luminous index. Luminous intensity. Intensity is candela, right? Measured in, maybe you call it index as well, right? Okay. Question number 8. Is it clear? Is it clear, everybody? Do you agree with the answer? Answer number 5. Answer number 5. Right. Everybody? Right. Oh, good. Question number 8. Balam. Which statement is a false about the elements in group 18? What are the elements in group 18? What are the elements in group 18? What are the elements? Shall I get the periodic table again? Periodic table again. Right. So this is the periodic table. You have helium, neon, argon, krypton, xenon, radon, and very recently added, very recent in the sense few years back, OG, right? Okay. So they are non-metallic in nature. What can you say? A. What can you say? A. Non-metallic in nature. True or false? They are all non-metals. True. They exist in diatomic form. What can you say? They exist in diatomic form. Is it true or false? That is a false statement. They all exist in monoatomic form. They are radioactive in nature. Are they radioactive? Of course, this OG, radon are radioactive. Other than that, others are not radioactive. So you can't say they are radioactive. Xenon is the most reactive among these elements. That is also wrong. Xenon is not the most reactive. Radon is the most reactive because down the group reactivity increases. That is a wrong statement. So fifth answer is the right answer, right? So you have to understand xenon is reactive, right? I am not saying it is not reactive. It can react with more electronegative element. But radon is much more reactive than that because it is at least radioactive. So it's more reactive. Radon is more reactive. Is more reactive. It says most reactive. So that is wrong. Did you understand that? So fifth answer is the right answer. Would you agree? Disagree? Any other thoughts? Any other thoughts? Is helium is monoatom? Yeah, helium is monoatomic. One atom. It can't dimerize. The 1s2, it's like, the outermost energy level is completely filled. Is it clear? What is meant by diatomic means, get the word properly. Di means two. Atomic means atoms. Two atoms combined together. What are the diatomic species? Hydrogen, 2 atoms. Chlorine, 2 atoms. Fluorine, 2 atoms. Nitrogen, 2 atoms. Oxygen, 2 atoms. Bromine, 2 atoms. Iodine, 2 atoms. These are the diatomic species. but it exists as gases. Of course, they are all gases. Yes, clear? Does the reactivity increases down the group? Yes, because the atom becomes larger and larger and larger so that the electrons can be removed easily, right? Right, okay, right. Question number 9. Right. The emission spectrum of hydrogen atom and the emission spectrum of lithium atom are almost identical. What can you see? What can you say? Emission, they are not the same. They are not identical. Why? Because Z is different. I told you energy, EA energy is equal Z squared R times 1 over N1 squared minus 1 over N2 squared. So if Z is changed, atomic number is different, they are completely different. So that is a wrong statement. What can you say about the other one? Hydrogen and lithium atom have only one electron in their outermost energy levels. Did you understand that? Is it clear? Right? Okay. So that is a true statement. Is it clear? Did you understand? If the reactivity increases down the group, Og should be the highest radio. So this is radioactive. It's a radioactive element. Og is a highly radioactive element. It's very unstable. So it doesn't exist that much, right? So, but then it doesn't matter, like, doesn't matter. Xenon is the most reactive among these elements. That is a wrong statement, right? Okay. Question number 9. It says false and true. What is false and true? Fourth answer. Would you agree to that? Is it clear? Right. Fourth answer. Question number 10. Question number 10 is this. Cations are smaller than their parent atoms. What can you say? Cations are smaller than their parent atoms. Of course, electrons are removed. Cations are formed by removing electrons. Electrons, outermost electrons are removed. So electron repulsion is minimized. And net attractive force on each electron is increased. So that electrons are condensed. The electron cloud become condensed. So therefore radius decreases. Cations are smaller than their parent atoms. I hope you will agree with me. That is true. It's a true statement. The number of electron repulsion is reduced in the formation of a cation. Electron repulsion is reduced for the formation of the cation. Did you understand that? So yes, right? It explains as well. This is not the only factor, but it explains. Electron repulsion is reduced. So that is why electrons are attracted towards it. So we can say it is one, right? But it is not the only reason, right? Net attractive force for each electron also is increased. And that is why both of those factors bring the electrons closer together. Why electron repulsion is reduced in a cation? Because in a cation you have lower number of electrons, right? Think about a cation. Think about a element like this. Look at this sodium, right? What is the electronic configuration? 1s2, 2s2, 2p1, and 3s1. How many? Through 2p6 and 3s1, right? How many electrons are there altogether? Altogether, you have how many electrons? 2, 4, 6, and 7. 11, right? 11 electrons. So there 11 electrons repel each other. Did you understand that? Like think about sodium plus. What is sodium plus? 1s2, 2s2, 2p6. How many electrons are there? How many electrons are there? You have only 10 electrons. Did you understand? Where do you have a higher repulsion? When you have 11 electrons or when you have 10 electrons? When you have 11 electrons or when you have 10 electrons? Right. When you have 11 electrons, it repels. Right. If you have 11 people in one room, they fight more. When you have only 10 people, they fight little less, right? Did you understand that? Is it clear? Everybody understood that. So therefore, there's a lower repulsion. But other than that, you ask me what is the other reason? Other reason is 11 protons. So you can see 11 electrons are attracted by 11 protons in sodium. In sodium plus, you still have 11 protons. Now 10 electrons are attracted by 11 protons. Each electron has a greater number of attractive force, greater force towards the nucleus. So therefore, the electron cloud get condensed. So, but you can take it as one because electron repulsion also, less repulsion also electron cloud. So what are the answers that you see? Answers that you see is first question, answer number 1. If you have any parts that you didn't understand, you have to ask now. Second one, answer number 3. Third one, answer number 2. Fourth one is answer number 2, carbon. Right? Fifth one is answer number 4. Right? Sixth one is answer number 4. Seventh one is answer number 5. Eighth one is answer number 5. Ninth one is answer number 4. 10th one is answer number 1. Can you explain why the first statement of 9 is wrong? First statement of 9. First statement of 9 is emission spectrum of hydrogen atom and the emission spectrum of lithium atom are almost identical. That is wrong. These are two different atoms. Two different atoms means two different, two different spectra, because it all depends on the Z, right? It depends on this Z value. Z value is different. Hydrogen, for hydrogen, it is 1. For lithium, it is 3, and it is different. Is it clear? What is this? Is the intensity on the 7th one is constant? Intensity depends on the number of photons given, right? If you have large number of photons, the intensity is higher. If you have less number of photons, the intensity is lower, right? Like nothing, otherwise nothing to do with that. Is the emission spectrum of hydrogen and lithium plus 2 the same? No, no, it's still different because the Z is different. They are different, right? Emission spectrum of 2 different atoms, even with hydrogen and helium, they are different. It's a very characteristic. I told you it's like the fingerprint of it, right? Okay. Why B is wrong in the 7th? The speed of the light doesn't increase. Speed of the light is a constant. Speed of the light right? You change the photon, speed of the light changes. Doesn't happen that way. Can you explain the 4th one again? Question number 4, right? Explaining the 4th one again. Which of the A, B, C, D are 4 consecutive elements in the P block, right? A, B, C, D are 4 consecutive elements in the P block. So consecutive elements, and the first ionization energy variation is given below. Right? First ionization energy variation. So first ionization energy variation is like this. This is how it works. Right? Group 1, group 2, group 13, group 14, group 15, group 16, 17, and this is 18. That is how the ionization energy vary. But then it says P block. If it is P block, these are not there, right? This is group S block. This is also S block. No, we can't consider these two because all these are belonging to group P block. So the other ones are the P block elements. And it says ACBD. A is smaller. C, B, D. What is the pattern? A, A is here, this is B, this is C, this is D. That is how the pattern is. A, B, C, D are consecutive, but compared to A, C is higher, compared to C, B is higher, compared to B, D is higher. So that means these are what? Group 13, 14, 15, this is 16, this one is 17, and this one is 18. So it means C belongs to group 6. This belongs to group 6 or group 16. What are the elements in group 16? Oxygen, sulfur, selenium, tellurium, polonium. And hydride is water, means hydride is liquid, means it is H2O, right? H2O. Did you understand? What about that group 13 might be A? No, 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 it can't be A. How can it be A? Think about it. If this is A, or I'm writing it in black color, right? A, this is B, this one is C, this one is D. How does the variation take place? A is the lowest, then comes D, then comes B, then comes C. And you don't get that pattern. ACBD pattern is not given if you take it like that. And think about it. Right? Is it clear? Right. That's good. If you understood, that's really good. Right. Okay. So I will erase that. Otherwise, it will be confusing. Huh? Can you explain why D part of question number 7? What is question number 7? D part. Intensity decreases. Intensity depends. It doesn't depend on the lambda value. It depend on the mu value. Intensity means number of particles hitting. Right now, for example, do you have a dim bulb? Right? You might have a bulb which you can dim. Right? You can rotate the voltage. I mean, not the voltage. Rotate the resistance. You can change it, and you can dim the bulb. In a dim bulb, it gives you less number of photons, number of particles. If the number of particles are higher, we say it is in the intensity is higher. Otherwise, if you look at one single particle, it has a specific wavelength and specific frequency, right? So when you change the wavelength, nothing happened to the number of particles. Will the number of particles change? No. If it is 100, it is 100. It doesn't change. It depends on the intensity. The intensity depends on the number of particles hitting on the. So that is why, like in the morning time, the number of particles that you are hitting, that you are getting hit by the light would be smaller, right? At daytime, you get a kind of a higher number, and that is why you get all hot and warm and all kinds of things happen because of that reason. Hari, right? Okay. So we will go to the structured essay part and then work it out. Right. Right. Question number 1. Select suitable answers for the following questions using given elements. Right? Given elements below. What is this? What is this? Aluminium, phosphorus, sodium, magnesium, chlorine, neon, silicon, oxygen, nitrogen, sulfur, chlorine, argon. These are the ones that are given. Right? Entire bunch of elements that is present. Right? First, does the intensity depend on the frequency? No. Intensity does not depend on the frequency. It depends on the number of particles. Right? No, it doesn't depend. The noble gas in the second period of the periodic table. What is your answer? What is the answer? What is the answer that you get? First one. Noble gas in the second of the periodic table is neon is the answer. Out of the lot that is given, I think neon is the answer. Which has the highest metallic character? Second one. Highest metallic character. Metallic character elements that are located in the left-hand side of the periodic table. Aluminium, phosphorus, sodium might be right. Magnesium. Yeah, sodium is the answer. Sodium. Why do you say magnesium? Why do you say magnesium? Right? Not aluminium. Not aluminium. Sodium. Sodium is the answer. Right? Then the third one. Which is the metalloid among these elements? What is the metalloid? Aluminium, phosphorus, sodium, magnesium, fluorine, neon. Silicon is a better answer. Silicon is the best answer here. Metalloid, it's a semiconductor and it has this metalloid properties, right? Fourth one, which has the second largest radius among these elements? What do you think? Second largest radius among these elements. Right? Second largest among these elements. Aluminium has metallic properties, not metalloid. Aluminium, it has a amphoteric properties more towards metal properties, right? Which has the second largest radius among these elements. Largest radius. Largest radius. Which one has the largest radius? Right? So when you go across the period this way, what happened to the radius? Radius decreases, right? So I think sodium has the highest radius. Second one is magnesium. Out of the elements here, magnesium. Did you understand that? 5. Which element contains the lowest third ionization energy? Lowest third ionization energy is for group 3 element or group 13 elements. Group 13 elements. So what is the group 13 element? It belongs to group 13. Which one is that? Aluminium is, I think that is good. Phosphorus, sodium, magnesium, fluorine, neon, silicon, oxygen, nitrogen, sulfur, chlorine, argon. So that should be aluminium. Agree with that? Right. Question number 6. Which element contains the highest electron gain energy? Highest electron gain energy. So there are right? There are positive values and negative values, right? When you have positive values, negative values are considered as lower, positive values are considered as higher. Now, last 3 chem meals, I have been deliberately discussing this for a long time, right? So this should have a positive value. Then only you get a highest value, right? Which one has the positive highest value? Positive highest value, can you tell me? What is the positive highest value? It should be what? For a inert gas, neon. Neon is the right answer, right? Neon is the answer. So this should be a positive value. Then do I have to remind that again? The graph, right? First one, right? First one, what is the first one? Right? So what is the first one? Sodium. Right. Okay. So if you look at this one, right? If you look at these elements, like these are group 1. I'm looking at the group wise, not per element element. So sodium has a negative value. Energy is given out. Magnesium has a higher value. Why? Because magnesium 1s2, meaning S2, and very difficult to gain electrons. Aluminium has a greater value. Silicon, like that. I will get rid of these elements and I will write it as group wise. Otherwise, we have a bigger problem. 1 here. This is group 2. This is group 13, 14, 15, 16, 17, 18. Right. 13, 14. Now 15, what happens to 15? 15 has a slightly higher value. Did you understand that? Right? 16, again, you have a lower value. 17, you have a lower value. And 18, you have a higher value. You understand that? Like this. This is how the variation takes place. Right? So if you have inert gases, you have a positive value. It gains energy. It gains energy. So group 18, there are two elements in group 18, neon and argon. Neon has a lower radius. Argon has a higher radius. So where do you think that the electron comes, like whenever electrons approach here, there's a greater repulsion. Here, the electron is given to a energy level far away. So here it gives out, not gives out, we need to supply a large amount of energy. This requires only a small amount of energy. So neon is the highest value. Right? Okay. What is the next one? You said that I missed one question. Somebody said I missed one question. What is that question? Did I miss a question? Are electron gain enthalpy values are assigned for noble gases too? Yes, yes. There are electron gain enthalpies for noble gases also. Noble gases also can, like, if you forcefully give an electron, it can gain an electron. Okay. So what are the answers? Answers are like neon, sodium, then silicon, then magnesium. Fifth answer is aluminium, and the last answer is neon. Okay. See whether we can work that out. Huh? Right. Part B. A is a transition metal in the ground state. Has only 6 electrons in the d sub energy level. What is d sub energy level? 6 electrons. Tell me what is that? D sub energy level 6 electrons. What was that? What was that? What was that? 6 electrons. What is that? 1s2. If I look at this thing, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6. That's what we are looking at. Is it clear? Everybody understood that? Right? So if it is that, what is the element? Element is iron. Fe is the element. Yes, agree with that? Everybody understood that? Right. Second one, it says, write the electronic configuration of the condensed electronic configuration of the above two elements. So how do you look at the electronic configuration of the condensed one? So here the electronic configuration is this. What is the condensed electronic configuration? The closest element. What is the closest element? What is the closest inert gas element that you have here for iron? What is the closest inert gas element? It's argon. Yes, you get argon. And what else? 3d6 and 4s2. Agree with that? So other than this electronic configuration, you are supposed to write this one as well. Is it clear? Everybody. Again. Yeah? Everybody understood? Right. Okay. Then what are the two main oxidation states of the above element? Right. So this third one, I want you to understand that perfectly well. Right? Oxidation state here, I told you this is a metal. right? This is a metal that is present. Everybody understood that? This is a metal. So if it is a metal, you can only remove electrons, you can't gain electrons. So I will write that. Metals remove electrons. Metal remove electrons. Right? So how many electrons can you remove? First thing, it can safely remove the electrons at the outermost energy level. You can safely remove the outermost energy level. So if you safely remove outermost energy level, we say it is +2. Removal is +2. So remove the outermost energy level. Remove outer energy level. Right? Outermost energy level, you can remove. What is the difference between the electronic configuration and the condensed electronic configuration? Can you see the difference here? Look at this. This is like written, everything is written there, right? Condensed electronic configuration means you write the nearest, closest inert gas configuration and the remaining part. We talked about this in the class, right? In the main session, we have talked about it, right? So remove the outermost energy level. Did you understand that? Other than that, you can see there's 3d6. So you can see 3d6. Let me draw that 3d6 as well. Right? So you have how many electrons? 5 electrons, 5 levels. 1, 2, 3, 4, 5, 6. But you know, half state is very stable. So it can remove this electron as well. Remove this as well. So when you remove other than those 2 electrons, when you remove, you get +3 as well. So these are the 2 oxidations. 2 oxidation states, +2 and +3. So you can write it down in somewhere in that paper. Energy level 2 electrons are removed. Other than that, out of D6, 1 more electron is removed to make it half filled. Last energy level 2 electrons are removed. 1 more electron is removed to make it what? Make it +3. Is +8 correct? That is wrong. That is wrong. Okay. +8, you can't remove electrons like that, right? There's a limit that you can remove, right? There's always a limit that you can remove. +2 and +3 are the ones that you have, right? Right, okay. Next one, represent the orbital diagram for the above oxidation states. Represent the orbital diagram for the above oxidation states. How do you represent the orbital diagrams in above oxidation states? So you have 1s2, right? That's the first one, right? Second one is 1s2, 2s2, and 2p3. Then what is the next one? 3s2, 3p6, then 3d, 5, and then 4s2. Let us see whether we have written that. So, right, this is 1s2. This is 2s2. This is 2p6. Right? This is 3s2. This is 3p6. Then what is the next one? This is 4s2, the last energy level. And this one is 3d. Right? Since to get some little bit of space, I made it small. 1s2, you have 2 electrons like that. 2s2 also, you have 2 electrons. 2p6, 1, 2, 3, 4, 5, 6. 3s2, you have 2 electrons. 3p6, 1, 2, 3, 4, 5, 6. Then the electrons are filled to 4s, 2 electrons. And 3d, how many electrons are there? 1, 2, 3, 4, 5. There are 6 electrons. You write it like that. Haridha Puta, did you understand that? How represent the orbital diagram for the above oxidation states, right? So if you are showing the above oxidation states, these last electrons are gone. These electrons are gone. Why? Because those 2 electrons are removed completely. So I will write, just for clarity, I will write it as Fe2 plus. This is Fe2 plus. Right. We need to draw Fe3 plus also. Maybe we'll copy it and then paste it here. So what will happen? Fe3 plus, this is what happens. Fe3 plus, what happens is this one. These electrons are gone. So let us correct it. Now you have one more electron. So here you have removed 2 electrons. 2 electrons are removed. Here you have removed 3 electrons. 3 electrons are removed. Did you understand that? How you write it in the orbital diagram? Is it clear? Everybody understood that? Sure? Right. Okay. Next one, draw the energy level diagram for the smallest oxidation state of the above transient metal. How do you draw that? Smallest oxidation state. What is the smallest oxidation state? Smallest. What is the smallest oxidation state? Out of this, +2, +3. What is the smallest oxidation state? +2. So smallest is +2. So we are going to plot this. Right? Right. So check, make sure to understand this well. So they say the energy level diagram. Earlier also there was another paper that we talked about energy level diagram. So this is energy. How does the energy vary? So this is 1s. 1s. This one is 2s. 1s. 2s is this. 2s. Then comes 2p. 2p, you have how many electrons? Like that. How many 2p? Then comes, what is the next one? 3s. 3s, one orbital. Then 3p. 3p, how many orbitals are there? 3p. After that, which one has the higher energy? After 3p, which one has the higher energy? 4s. Then only 3d comes in. 4s, you have 2 electrons. 3d, you have 5 orbitals, 10 electrons maximum. This is the energy level. This is how it is appearing, right? This is how the energy varies, right? Okay, so electrons 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 2, 1, 2, 3, 4, 5, 6 here. From the 4s, there were 2 electrons, but those 2 electrons are now gone. They are not there, right? These are not there. So what I'm going to do is I'm going to erase that 4s. Right. This is what you have. This is your oxidation number +2 with the lowest energy level for the transient state. Do you have questions there in that part? Is it clear? Right? Is that clear? In this part, in this Fe +2, Fe +3 oxidation state, do you have any questions? Any questions that I should be addressing on? Is it clear, this section? Do we have to name the 4s orbital? It's better to write it, right? Better to write it, and you can, if you want, you can show it as well. But then there are no electrons in it, because those electrons are gone there. Can't it be Fe +1? No, you can't. It can't be Fe +1. +1 oxidation states are not there, except for copper plus. Other than that, others doesn't have +1. For 3D elements, +1 oxidation state is not there, right? Okay. So I think that is okay. Cannot we keep the 4s orbital without erasing? Yeah, you can keep 4s. Please keep it. It's okay. Because it's there, orbital is there, but not the electrons. The electrons are not there, right? Okay. Right. Shall we go to the next question? Should I write both configuration when they ask for the electron? No. You don't have to write both configurations when they ask for the electronic configuration. When they say electronic configuration, you write the lengthier form. Write the lengthier form. Other than that, you write the normal, like, if they say condensed electronic configuration, you can do that. Is it clear? Everybody understood that? Right? Okay. Part C. Whether we can answer this one. Define the term electronegativity. What do you mean by electronegativity? It is what? Electronegativity means what? It is the ability to withdraw electrons towards itself while it is in a chemical bond. Did you understand that? Can you write down? It is the ability to withdraw electrons towards itself. While it is in a chemical bond. Did you understand that? Right. Okay. So, you are saying the same thing. Can we say ability to attract electrons towards itself when forming a chemical bond? That's what it is. Only thing is you have slightly different words. That's okay. Right. That's not a problem. Right. So you don't have to write the same sentence. Right. Yeah, sure. What is the periodic trend for electronegativity? What is the periodic trend for electronegativity? If you look at the periodic from the left hand side to the right hand side, what happened to the electronegativity? Electronegativity, what would happen? From the left hand side to the right hand side, electronegativity increases, right? And then to the right hand side to the left hand side, electronegativity decreases. Clear? Down the group, what would happen? Electronegativity decreases. Up the group, what would happen? Electronegativity increases. So left to right, at least top to bottom, bottom to top, and right to left. These four things you can write: increases, 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 decreases, decreases. Can you manage that? That's your answer, right? Third one. Which element in pair has the higher electronegativity? Which one? Carbon, nitrogen. Very simple answer. First one, nitrogen. Nitrogen is 3.0. Carbon is what? Carbon is 2.5. In chemistry, do we have to use the exact term and wording in writing definitions, resource book? No, you don't have to. It's not biology. Chemistry is chemistry, right? You can write in your own words, right? Okay. So B, part B, sodium and potassium. Which one has the higher electronegativity? Down the group, electronegativity decreases. So with higher electronegativity, sodium, potassium. Sodium is the. Everybody understood that? Right. Then the fourth one. It says, state the increasing order of the following properties. First one is atomic radius, right? So magnesium, phosphorus, silicon, and argon. Right. So how does it work? First one, you look at energy levels, then number of protons, then number of electrons. Energy levels, how many energy levels? Magnesium. How many energy levels is magnesium? Again. Magnesium, how many energy levels? Magnesium is 3 energy levels. Phosphorus, 3 energy levels. Silicon, 3 energy levels. Argon, 3 energy levels. Everything is 3. Number of protons, magnesium is 12. Phosphorus, I think 15. Silicon is 14. Argon is 18. Did you understand that? Electrons are also the same, like no cations, no anions here. So 18. Right. Since the energy levels are the same, all depends on the number of protons. Higher the number of protons, lower the radius. So what do they say? Increasing property. That means argon has the lowest radius. Then comes phosphorus. Then comes silicon. Then the next one is magnesium. Do you agree with that? Argon is the smallest, phosphorus, silicon, and magnesium. Look again. Everybody? Right. So that is the answer, question number 1 in that. A. Sorry, not A. Right. Let us look at the B. B, first ionization energy, beryllium, boron, fluorine, and oxygen. First ionization energy. We will draw the first ionization energy diagram. So first one, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So what do they ask? They ask you to arrange order beryllium, boron. Boron comes, the lowest is boron. Then comes beryllium. Then what are the other elements? Fluorine and oxygen. Oxygen is lower, fluorine is higher. Would you agree with that or not? Look again. Did you understand? Harini? Right. Okay. Good. C. Then the next one is, it says electronegativity, boron, carbon, silicon, and phosphorus. Like, just to remind you, I will write down the electronegativities. Neon, we forget about it, right? Can you tell me the numbers? Can you tell me the numbers? Fluorine is 4. This is 3.5. Nitrogen is 3.0. Carbon is 2.5. Boron is 2.0. This is 1.5. This is 1. Harane the shape ne? Can you remember? 0.5, 0.5, 0.5 drop. Then chlorine is 3.0, 0.5 drop. Matakaini? I told you it's 0.5 drop. What is the next one? 0.4 drop. What is the value? 2.1. Then after that, 0.3, 0.3, 0.3, right? So 1.8, 1.5, 1.2, 0.9. Hydrogen, what is the value? Can you tell me, children, what is the value of hydrogen? Hydrogen 2.1. Very good. Shah, oxygen, sulfur, then, no, sorry, fluorine, chlorine, bromine, and iodine. What are the values? Bromine and iodine, what are the values? Bromine is 2.8. Iodine is 2.5. Right? Right. Okay. So now I think you know the values. Let us say the lowest one. What is the boron, carbon, silicon, phosphorus? Boron, carbon, silicon, and phosphorus. Silicon is the lowest, right? Silicon. Boron, carbon, phosphorus. Boron, carbon. Boron, carbon. Silicon, phosphorus. Nada. Right? You know which one is that? Boron, carbon, silicon, phosphorus. Wait, I'll boron, carbon is this, boron is this, silicon is this, phosphorus is this. So what we need is the highest value. Carbon is the highest value. Then comes boron. Then comes phosphorus. Then comes silicon. Silicon, boron, silicon, boron by silicon 1.8, 2.1. Yeah. Okay. What are the values? Silicon, boron, phosphorus, and then comes carbon. Silicon 1.8, boron is 2.0, phosphorus and carbon. Right. Okay. Agree with that? Everybody agree with that? Then the next one is second ionization energy of these ones. Second ionization energy of this means second ionization energy is lowest for group 2. Group 2 is the lowest. So group 2, so that's how the variation take place. So group 12, no, not to 12, what is this? Group 2, 13, 14, 15, 16, 17, and 18. And group 1 is the highest. Group 1 is the highest value. So what are the values that you get? How do you get the values here? So the what are the elements that you have? Let us mark the elements. This is beryllium. Right? So lithium is somewhere here. Group 1, lithium. Second ionization energy is lowest for beryllium. Then what are the other elements? Beryllium, carbon, nitrogen. Carbon, nitrogen. Then comes carbon, then comes nitrogen, and the highest is lithium. Check whether you are okay with that. Beryllium, carbon, nitrogen, and lithium. Is it clear? Beryllium, carbon, nitrogen, and lithium. Right? Somebody says, can you please explain part B in this question? Can you explain part B in this question? Part B is what is part B? This is how the ionization energy vary. Ionization energy vary in this order. Ionization vary, right? How does it changes? Beryllium, boron, fluorine, and oxygen. Beryllium, boron. Boron is the lowest value, right? boron, then comes beryllium, then comes fluorine, then comes fluorine, sorry, then comes oxygen, then comes fluorine. So beryllium, boron, oxygen, and fluorine. That is how it. What is more electronegative, carbon or sulfur? Sulfur is more electronegative, right? Sulfur is more electronegative, right? Milesh, if you want to sleep, you can sleep. Right? I think, Amina, you asked this question so many times, so I decide not to answer. Right? Many times. Okay? Right? So neon has a higher electron gain enthalpy. Okay? Right. I think that is it for today. Right? I think we finished this. Okay. Right. Oh, thank you very much. Right? Okay. Bye. Good night. Thank you.